Good evening, everyone watching from the stream at this new virtual DDD. With me are Gayathri and Andrew, and today they're going to take us on combating the near enemies of domain-driven design at scale. They will do their talk, and afterwards we'll have questions and discussions, and everything is open. So join the Zoom if you're on the live stream, or just sit back and relax and ask questions on YouTube. Welcome.
Cool, thank you very much. Thanks for dialing into our talk. Like Kenny just said, the idea is Gayathri and I will kind of go through the presentation for what we hope will be 45 minutes, and then we'd love to have some questions because we've made the talk kind of not simple, but we tried to focus it in, and then we know there'll be loads of stuff that people ask about, more detailed questions and stuff. So we love to have people's kind of detailed questions and things. So that'd be really good. So it's maybe not relevant for this screencast, but we like to kind of start off just to make things clear. So when we talk about domain-driven design, what we mean, because it means a lot of things to a lot of different people, is fundamentally the pure concepts that were introduced by Eric Evans in the famous Bluebook. And so when we say DDD or domain-driven design in the talk, that's the stuff that we're talking about. So quickly to introduce ourselves, I'm Andrew Harmel-Law.
Are you sharing the screen?
I think so. Am I not sharing the screen?
No, you're not sharing.
Oh, no, it's not sharing. Wait, sorry, I'll start again. There's the screen.
No problem.
Yeah, sorry. Here we go, and I'll press play.
There we go.
Yeah, we can see.
Yeah, there we go. Sorry. So I'm Andrew Harmel-Law. I'm a tech principal at ThoughtWorks. But what's relevant for the session tonight is that I'm a Java developer and a Java architect, and I've led lots of development teams, working as a consultant in ThoughtWorks and other companies. I've worked in lots of different industries, but I've built lots of things using DDD. So I've built more traditional monolithic services, lots of microservices-based systems. And I've used DDD, like I say, in lots of circumstances to kind of solve some of the tougher problems which we've encountered trying to build big systems with lots of people.
Hi everyone, I'm Gayathri. I'm an engineering lead at Expedia Group. Like Andrew, I'm a Java engineer by profession. I've been doing Java development for the past 15 years. I've worked on many projects, mostly microservices and DDD principles applied in those projects as well. More recently, I'm leading a big data capture platform based on event sourcing and DDD concepts.
Sorry. So there's a kind of term that we've taken from another kind of completely different discipline, and that's Buddhism. And the term is the near enemy. And so we're aware that people probably don't understand what a near enemy is. So we thought we'd find a good quote to explain it. And it's a really nice lens to look at things, to kind of use it to think about why things might not be working. So the quote here explains what a near enemy is. So near enemies are counterfeits of what we're actually aiming for. And so counterfeit is the important word. So it's something that's a very close copy, maybe something which when you look at it quickly, or you don't look at it in an expert way, then you think it's actually the real thing. But they're unhelpful because while the genuine article helps free us or has value, the counterfeit doesn't. And so therefore it's a nice lens for looking very closely at things to figure out why something is a counterfeit and why something's not actually giving you the values that you're looking for. So we're going to use this lens to look at domain-driven design, but some examples of how you might use this to look in other places, just to maybe to bring this to light. You could use this lens to look at agile adoptions or DevOps practices, for example, because as probably most people listening and watching have seen, they'll see how well, but then they aren't really realizing benefits. And they're probably falling for near enemies of agile, or the same thing for DevOps. So what we're going to do, and the kind of the main spine or the structure of the talk is we're going to talk about a project that Gayathri and I worked on. We've changed lots of details to make it a better, more interesting and more valuable talk. And we've also brought in pieces from other projects that we've worked on. But fundamentally, it's a story of a project we worked on, which had the aim of modernizing criminal justice. And because we picked it because criminal justice and the law and the legal system is something which everybody in all countries have. So it's a domain which we can talk about in some detail, and probably everyone has some idea of how they think the system works. So this project had a timeline. When I started working on this project, it had already began. So I started after the project had been spun up, and I took over from another domain-driven design expert who actually left before I arrived, so I didn't get to meet them. And then sometime later, but well before the project finished, I rolled off.
And then I started, and mainly since I started on the project, my focus had been in implementing all the models that Andrew had discovered, more on that later, until I kind of rolled off the project 12 months later. Yeah,
and when it was still going as well, right? So, so also, because we're talking not necessarily about a real thing, but something which is based in real experiences, we'd like to tell you about some of the key constraints which we're going to apply to this story. So again, to try and make it more realistic. So here, it's important to realize that we're talking about modernization of an end-to-end justice lifecycle. So we spanned multiple organizations, which was one source of lots of the complexity. Number two, as we already said, but it's important to make it clear, the teams were already identified and code had already been cut, and so lots of design had already been done, which is hopefully a kind of a thing that lots of people can relate to here. You very rarely get to start with a greenfields project. And also, and this is what we'll talk about at the end of the project, CQRS was being used everywhere. Every single microservice that was being built in a CQRS style.
But what was quickly clear when Andrew started, and after that I picked up, was in spite of all these constraints, the stakes was incredibly high because this was a high profile public sector project, right? So in terms of benefits, if the project was successful, and also risks in terms of reputation if the project failed.
So we split the talk into three parts. The first part we'll talk about mainly about the work that I did when I arrived and kind of set about doing lots of investigation, and then it kind of concludes with some recommendations that I made. Then the second part will talk mainly about how Gayathri took those and tried to bring them to the teams and bring the benefits to the delivery. And the third part will talk about how CQRS sat in all of this environment. So let's talk about the first part. As I said, when I arrived, things were already up and running. So what I first did was I tried to get as much information about what was already there as I could. So I looked at the designs, which were in lots of different places. I looked at the code. I looked at the organization of the teams and how the teams were interrelated. I looked at official sources of information because there was lots of stuff on wikis and in design documents, but also unofficial sources of information. So you could see teams that had little whiteboard pictures and lots of things like that. And like I say, I also looked at the teams, but most importantly, the lines of communication and the dependencies between teams and like how they were blocking each other. The big focus at this point was to make sure I didn't get sucked into too much detail. It was an incredibly complicated domain, but I couldn't afford to get sucked into one problem when I needed to find out how big the overall problem was. And so what did I find? There was three key findings which came out as a result of this kind of first phase. Number one, and this wasn't a failing, this was just a fact of life, because it was an end-to-end justice lifecycle, no single domain expert had a detailed end-to-end view. So because we were talking to domain experts from the courts, from the state prosecutor, from people like the police, and people from defense attorneys or solicitors or whatever they're called in your country, they all had a very detailed view of their piece of the system, but no one had an end-to-end view of all of the detail of all of the system. Number two, and this was a problem, there was no obvious big picture of different places, but just like there's this map behind this, the words on this slide, you know, which you can see overall how all of the countries in the world kind of generally fit together, there was nothing of an equivalent to this. And as a consequence, the cognitive load was very, very high, much too high. So a team who wanted to build their components, they needed to know lots of details about lots of other systems. There wasn't somewhere to go to get a big picture. And that was affecting teams. So this brings up our first near enemy. The design has been done, but it hasn't been laid out in a way that makes it consumable. And so a combat strategy for this, make sure all your design artifacts are created with the audience in mind. And that includes introductory artifacts and things that help teams find where their piece of the system sits within the bigger picture of the overall system. So that's a kind of general thing, but there was one thing, and there was a lack of an overall picture. But there was also something which was, which I've discovered which existed in lots of different places, which was a surprise. And this was a phrase which I kept hearing, which is a case is a case is a case. It wasn't clear where this came from, but it was likely came from the desire to reduce duplication, because what it basically had been interpreted to mean was a criminal case is a criminal case. It's the same thing wherever you look at it, however you kind of come across it, it can always be seen in the same way and represented in the same way. So therefore, what you saw in the code base was there was a case class, a gigantic big case class, which represented a criminal case. And because we were doing microservices-based architecture, this was packaged as a microservice. So it was a single independent deployable component, which whenever any other team which were building something needed to have a representation of a case, they would have to add some functionality to this module, and then they would package it and redeploy it. And so what was we were experiencing here was possibly the fact of something which had arisen from a desire to reduce duplication, because we didn't want representations of cases all over the system. But we'd fallen into the trap of assuming that things that sounded similar, and we thought they were that, so, people had decided that they were the same. Although unfortunately, as you can see here, there's two twins. They're obviously very, very similar, but they're not the same people. They're different people. And what came to light as we looked at things in more detail, and as the teams were building more and more parts of this system, the differences became more and more significant, and the similarities became less and less. We're definitely, not realizing the benefits that we thought we would get. So let's look at an example, because this is a bit generic. So if we're kind of looking at things from a richer domain perspective, we would expect to find in the code base the concept of a case, but we'd also expect to find representations of the key people who would play a part or a role in a case. So if you think about your favorite TV shows, you probably can imagine that you have a suspect, who's the person who's suspected of a crime, or if you're watching a court TV show, then you'll have a defendant because the suspect has been charged, and now they're defending themselves in a court. But it's not just suspects and defendants. You'd also expect to see other people as well. So you'd probably expect to see victims, because most crimes have a victim. You'd expect to see someone like the police or another investigating authority. And you'll probably expect to see a witness as well. You'd probably expect to see witnesses as well. You'd also expect to see case materials. So case materials are, for example, things like pieces of evidence, so physical evidence, or witness statements or victim statements you have in some legal systems. And these aren't just kind of individual pieces of case material, but they have very specific and very detailed relationships with not just the case, but with the defendant or the suspect or multiple witnesses or whatever. So if we were, looking at a DDD code base, we would expect to see this richness in the code base. We'd probably expect to see something like kind of these concepts somewhere in the code base. But when we looked for things, they weren't there. What we saw, in fact, was this. So again, driven by the same kind of motivation which had made people think that a case is a thing which can be generified and abstracted, people had realized that all of these witnesses, suspects, defendants, etc., were people. Excuse me. So what we had was a class, and all the domain richness, so like a person being a witness or a person being a suspect, had been abstracted down to the names on the relationships. So you just saw them in a case. And the same thinking had gone even further, which had driven us in the past to make case into a microservice, because person was shared, person was a shared microservice as well. So they weren't, this led to the problem that not only were these concepts in code very abstract, but also they were in separate repositories. So therefore, being able to go to one place and find a kind of coherent view of the code and coherent view of the domain was completely lost. So this brings us to our next near enemy. Similarities have been spotted and abstractions have been made, but important differences have been lost in the process. And the combat strategy: capture the richness of the domain in the core entities. Don't abstract too early.
So we come to the next problem, which is the data centricity. So this was an important but overlooked side effect of the case is a case is a case doctrine. And also further simplification of the other core entities that Andrew just talked about, such as the defendant and the case material. But this had inevitably pushed into a data-based view, and you could see that come across in all parts of the architecture. And this was achieved at the expense of a process and behavior that should have been quite clear in your design, but it wasn't. Next slide. But this also manifested in a different way, which was through code merge conflicts. It's quite clear the way that Andrew described these cases, that this is fundamental to all the features that these different teams were working on. So any feature or story that any of the teams working on, this case class needed to be modified. So you can imagine the merge conflicts this had caused. So in order to work around this merge conflicts, the teams came up with a very clever idea where they assigned a baton, which was fundamentally a rolling pin. Nothing very complicated in that. So whoever held the rolling pin was the team who was allowed to merge the code, and the rest of the teams had to wait until they could get hold of the rolling pin. While this solved the problem of merge conflicts in a way, this hadn't fundamentally addressed the root cause of why these merge conflicts were arising. But also on the other entities such as defendant and case material, each of these feature teams, for the features they needed to build, they needed to add richness to these entities. But instead, they had to do with the diluted models because this was shared with all the other teams, and they had to go with a common denominator. So they were unable to add any richness that their own domains often demanded. So once again, prioritizing the data, we have actually forgotten about the process and behavior and all the richness of each of these domains the teams dealt with every day. So as a result, there were conflicts between the teams and a lot of team friction because of that. So the combat strategy to avoid this is share models and code only when it is absolutely essential. Otherwise, it can become really difficult to manage this at the ground level. So let's just stop and think about what are the fundamental problems that these teams were facing at this stage. First, one model to rule them all, even though it was born from a valid desire not to duplicate information across the platform. This had inevitably led to a lot of complications at the code level. Next, design decisions were made with only part of the domain information, and more importantly, trade-offs were made based on that as well. Similarities were identified based on names and attributes, and even sometimes just values of these attributes. And last, models were only about data. Behavior was forgotten and left out.
So before we finish the kind of the investigation section and the discussion of the situation which we found things in when we first arrived, there's another thing we needed to talk about, and that's one of ownership. So when I arrived, like I said, was replacing a domain-driven design expert. And so my job was just to replace them, was to be the new domain-driven design expert. And so I'd go to meetings and I'd be introduced as, was even once described as the domain-driven design messiah, because I was quite enthusiastic about the benefits that this could bring. But this resulted in lots of problems. Fundamentally, the problem was people thought I was there to solve all their problems, and I was there to do the design. So therefore, they would have to, they wouldn't need to do the design because it would be my problem. Also, because I was supposed to be there as a domain-driven design expert, I wasn't embedded with any individual team. So to get closer to the code and to get to kind of, to be able to manipulate the code and really work with the domain and the models of that domain was very difficult, because I was supposed to be kind of above the teams and kind of giving them information and telling them what to do. So it's definitely not the right way to do things. So fundamentally, the problem here is that hands-on modelers aren't hands-on. And in this case, this was me. I wasn't hands-on. I didn't get to manipulate the models. I was just drawing lots of things on whiteboards. And I wasn't trying to use that to solve real-world problems. And so the way to solve this, and the way I began to manage to solve this at the end, was making sure that I got to manipulate the code alongside everyone else. And this can even be used with team members who can't code, because you can pair them with people who can code. So you can get, your domain experts trying to work with the code by sitting them down with a developer.
So what about the other side? So if you don't recognize this is the other side of the dark side of the moon. Even though Andrew was initially brought to solve a lot of problems, the problems were not going away, such as the rolling pin, the merge conflicts. The teams were still experiencing significant pain when it came to committing the code. So that's day-to-day work, right? So when I started picking things up from Andrew, I realized that these models that Andrew had in mind needed to be realized and implemented in the code. But it also struck me that there is significant history behind the DDD practice in the project. Basically, the teams had experienced significant amount of pain having practiced it in the past, mostly that hadn't gone down well. Or it was more for the new developers, it was like a must-be-done step, mostly coming from the top, mainly because of its association with CQRS and the aggregates. But the team never really bought the idea of domain-driven design practice and haven't really seen the benefits of practicing it. So this was a culture change that needed to be addressed. While this was going on, there was the group of architects who were of the opinion that they needed to own these models and be the gatekeepers. So this was at risk of creating another problem where the domain knowledge was going to be restricted amongst the small subset of people, and the developers who needed to be iterating and implementing that model were removed from actually doing anything with it. So this is a classic near enemy, which many people can relate to, I'm sure. So DDD being done to the teams rather than by the teams. And to combat this, the modeling needs to be done by the team, and the team needs to own the models as well. It's important that these DDD practices are grown organically, even if it takes time for the teams to buy into these concepts. This needs to be organic and needs to come from the team.
So that's the first section over and done with. But before we go into the second section, we want to make sure one point is clear. While, as we've talked about, there were kind of lots of things we disagreed with, and there were kind of lots of problems that we could point out where things had gone wrong, or where things hadn't kind of realized the value that we were hoping for them to. But as we'll see in the second section, there was valid reasons why these things arose. And we've, if we're being honest, most people, like I definitely have kind of been engaged in projects earlier on where you make a decision which seems to be like a simple decision, and later on it kind of grows arms and legs and gets much more complicated. And there's some key points that we need to bring out as well. And the core point is that legal systems are necessarily complex. So number one, legal systems, wherever they are in the world, evolve over significant periods of time, and they explicitly represent history and the future in their models. So not only do the laws of any country exist in the past, the present, and the future, and they can be applied in the future, in the past, and the present as well. Things also expire within legal systems. Things have deadlines in legal systems. So time, which is always a hard thing to model and thing to work within software systems, is fundamental to them. To operate as well, definitely in the legal systems that I've worked in a few, they must bring together a great number of independent and probably hostile parties. So they're not going to bring together a bunch of people who are all trying to work to achieve the same goal. They're almost very definitely likely to be have a bunch of competing parties who are trying to achieve very different goals from the same legal system. And most fundamentally, legal systems operate on a set of core principles, specifically fairness and swiftness, which mean that a case must be resolved fairly and quickly for an individual, whether they're found guilty or whether they're not. These principles and these concepts must not be lost in any digital transformation, because if we did, we would be delivering a system which might be more efficient, but it would lose the spirit of the law. And so given all of these things, and this is why we're pointing this out, it's important, you know, it's quite incredible that the system had got as far as it had, because there were so many different things to balance.
Undoubtedly, domain-driven design is a perfect fit for such a domain. Remember, on Bluebook front cover, you can see the tagline being tackling complexity at the heart of the software, and it cannot get more complex than a legal system. And as you'll see in the subsequent slides, we had some really good foundations to actually work on top of.
Okay. So now we'll talk about part two. So this is taking the things we'd found and then trying to come up with new solutions. And as we go, we'll talk about some other mistakes, but this time it's mistakes which we made, so that you'll find a lot of the things about the mistakes I made and that Gayathri later cleaned up. So the first one we're going to talk about is coming up with a new way of looking at how things fit together. We've already pointed out that you need a big picture, because you need to be able, for individuals, developers and people who are working on the system, they need to know where their piece fits in the bigger picture. And we've also talked about how the model of using a case as a case as a case doesn't fit together. But you do need some model, right? We do need to have some kind of view of how things fit together. And so things that we need to bear in mind is that the legal system, and this might not apply to the systems you build, but the legal system is very process intensive. So here cases pass through multiple organizations and multiple owners. So we realized that discovering the spine of our solution turned out to be a breakthrough step in finding a new big picture. And how did we find this spine? We looked at the end-to-end process from a kind of high up abstract level. But before we start doing that, let's highlight the next near enemy. So it's very easy to point out what's wrong with any high level view, but that doesn't mean that you shouldn't try and have a high level view. Because if you don't have a high level view, you'll definitely fail. So therefore, the combat strategy is don't go away with nothing. And the key way to find a kind of key angle into this is to look at the relationship between your models. So doing just enough modeling to find a few different models and then looking at how they interrelate, that's a key way to kind of start trying to find your bigger picture model. So let's remind ourselves why we'd ended up with this shared case model. And we had a good bunch. Remember, we're modernizing criminal justice, so we've got a good selection of reasons why we wanted to share the case model. Number one, because the legal systems are typically paper-based, data consistency, when you're digitizing things, becomes a real headache, because human beings are filled in lots of different things in lots of different pieces of paper in lots of different places across a country. So data consistency is a problem, but if you digitize things, you should get, with a shared case model, data consistency. If you've got data consistency, then you can do reporting on things. So you can kind of get a summarized view of all of the data, specifically the cases in your system. And when you've got reporting, then you can do planning. So if you can imagine, one of the big business arguments for doing this modernization was we can have consistent data, so we can report on it, so we can see what things are happening in our criminal justice system. And therefore, when we have this data, we can plan and we can resource things properly and we can schedule things properly, and we'll get, justice will be seen to be done faster and more efficiently. So that's a really good, for a public sector project, this is a good argument, right? This is something that you'd want. Additionally, security was a key thing, and people were concerned about the fact that if it's all digital, then maybe people can access data they can't. But the idea was, if we have a shared case model, then we can have one place to control everything, so we should get simplified access control. But there's a problem with all of these four things. We've, here we've highlighted all of the benefits that are technical, but we've forgotten about modeling, building a system which actually helps us, manage cases in a criminal justice system. And we've forgotten these completely. They've suddenly become secondary. So we'll now start looking at, one of the problems which arose about this. So we've talked about, sorry, I'll just look for my notes. Yes, so we're looking back at case again. And remember suspects and defendants. We can see how a suspect and the defendant is, if we're looking at a case, they're just different views of the same person, depending on which stage of the criminal justice system you're looking at. So if we take a different view, and we start looking at the views of a case from the different parties who are kind of looking after and owning a case as it moves through the criminal justice system. So the first people who probably own a case are the police or another group of investigating authorities. And here you can see they haven't charged this person, so therefore they have a suspect at this point in the case. When they decide they have enough evidence and they want to charge this person with a crime, they will then pass the ownership of the case on to the state prosecutor, and then they will have their view of a case, and that person will stop being a suspect and will start being a defendant. And then if the state prosecutor decides to take that case to court, we'll then pass some of the control of the case over to the judiciary, so the court system, and they will still have a defendant, but they again will quite possibly have a different view of the case as it moves through the system. So what we have here is, we'd focused on the technical things and we were realizing the technical benefits, but we'd, in the process, ended up with a single view of a case, which made solving the domain needs and building a business system really difficult. So we solved one problem at the expense of another. And so this is where, again, where domain-driven design comes in super useful. There was a tension between these two needs, and what we'd done, or what had happened was, one had been chosen as more important than the other. But what we could have done instead was use domain-driven design to solve the tension between these two problems and solve both of them at the same time. And you can use these DDD tools to make these solutions explicit. And so the solution that we thought we came up with was a potential possibility for an abstract core. So an abstract core is quite a specific and not necessarily frequently adopted aspect of domain-driven design, but it's something that when I was looking at things, it thought that it might actually be useful. So it was clear when I was speaking to experts, domain experts from the police, they would talk about what they called a pre-charge case. State prosecutors would talk about what they called a prosecuted case, or the judiciary, they would talk about a simple justice case, for example. But it was also clear that the police would talk to the state prosecutor and they would just talk about the case. And they would know enough, they would know that they had different copies and different views of a case, but they knew that they had enough in common in that it was the same kind of thing that was progressing through the legal system, that they would be able to communicate and share information. And the same thing when the state prosecutor talked to the judiciary. So what we then had to do, with knowing all of the detail of what these different views of a case were, we had to find out what the shared view of a case was, our abstract core of a case, and this is what we came up with. So there were certain things, and there were very few, but there were certain things which they could all agree on, which an abstract case would represent. So number one was a thing called the case ID, and it was actually the foreign key in a shared case system that they had built in the 1980s. But they would all talk about this case ID, and they all knew that they were talking about the same thing, even though the old system had long been retired in the past. They also knew there was a prosecutor reference, so that would refer back to the person doing the prosecuting. The prosecuting authority was always shared as well, which would typically be the state prosecutor, but sometimes it would be a different authority. And also the investigating authority, which would typically be the police, but there were other authorities that had legal powers in this system, which might also be able to do investigations. So that was a case, but a case also always had something which it turned out and this was domain language which they used, they would call a subject. So a subject was the generic word that they used to describe either a suspect or a defendant, and they called it subject because they would know that they wouldn't then fall into the confusing trap of whether they were talking about a suspect or a defendant. And the last thing was case materials. So it turned out that when they were talking to us about case materials when we were doing the initial investigation, again, they already had another abstract term to talk about, like I said, all the things like pieces of evidence and all these different things. So you can see here we've got a very simple abstract core, but at the level which all the different representations of a case could all agree on, and all of these were realized in the specific versions of the case model. So it's time to point out our next near enemy. So what we had with the case as a case view was an anemic abstraction rather than a focused abstraction, which is what we arrived at later. And the way to get there, don't jump to abstraction. We were lucky because we got to dive into the details of the specific views of a case from the different perspectives. And then when we had the specifics, we could find the pieces that were common, which were shared between those different views.
So in the interest of time, I'm going to kind of jump through the slides so that we leave enough time at the end for discussion. Okay, so we keep coming back to the implementation of what's actually in the code, right? So at this point, all the three models and the abstract core that Andrew had found were still on paper or whiteboard or on Confluence. On the ground, we still had this one big case model, but what had changed was the teams had realized that they needed to do something about it. So what we actually expected the teams to have done following those modeling sessions was to see this, but what actually ended up happening was without doing proper design, the teams went about hacking the single case class into 3 pieces. So the result of which was we still ended up having those other parts of core entities, such as the defendants and case material, left out of the implementation or outside in separate contexts. So the cohesive view of that, because the modeling was not followed through by a proper implementation. So this was, while this was a great start, we still had lots of problems, and a big bang approach was not going to work because this hacking exercise already took significant amount of time from the team's timeline of delivering the features. So it was very clear that we had to do it incrementally and iteratively. So it brings us to the next near enemy, which is abstract concepts mean very little if they're not understood or implemented properly in code. So to combat this, always incrementally step towards a final model. And also it's important that while incrementing, don't assume that the initial assumptions made while modeling are always correct, because you always unearth new concepts. So it's always good to challenge your model while you're implementing them. So while this hacking exercise was going about, there was another risk that was coming up in the horizon. So which was following this splitting up exercise, one of the core teams was dying to go off and be able to do things on their own. So this kind of brought to light that there is a difference between being able to freely do things operationally, be able to release independently of other team. But also it was important that these teams had to follow a consistent thread of model. And remember the abstract core that Andrew had found. Without that, it was quickly evident that when the first stage of the criminal justice procedure was complete, the case gets handed over to the next team or the next stage in the process. Without this consistent thread in the model, it would have been really difficult to get this process end-to-end implemented in the same way as it follows the real life process. So the next risk that we were facing was the silos forming off back of these splits. So which brings us to the next near enemy, which is because of premature splits, it could lead to silos. Silos are very hard to recover from. So when you're thinking about splitting the bounded context, always keep an eye on the end-to-end process and how the teams come together as part of those domain processes so that things don't get lost in cracks. So Andrew talked about this 10,000-foot view, and this was still not clearly communicated to the teams who are actually implementing these processes. This was evident because some of those lack of high-level view actually manifested as complications and complexities within the code, or on the other end of the spectrum, oversimplification, where the domain actually demanded far richer implementation. So we came to refer to these as icebergs and ice cubes. To give a quick example of what an iceberg is, where the significant richness was hidden and not very clearly communicated to the teams, we had to put together as one of the features that the teams were building was generating a prosecution case bundle, which is nothing but putting together statements and witness statements, evidences into a bundle for each defendant, which could be shared with other parties in a case, like defendants or court prosecutors and defense solicitors, etc. So this actually sounded initially like a simple PDF generation process based on a few documents stored digitally. But actually, this actually turned out to be far more complex and rich, because this was a key stage in the prosecutorial process where the prosecutor goes through the process of allocating each of these case materials to each defendant. Sometimes they discard some of the materials if they don't think that's going to support the prosecution or is going to actually back their evidences. So they kind of discard it, and they have to keep track of the materials that they discard as well. So all these, without understanding the complexity in the domain, was at risk of getting lost by actually oversimplifying the problem statement. But on the other end of the spectrum, as we saw, significant amount of complexities was introduced, where some of the things were quite obvious if we had delineated the models in their own bounded context. For example, simultaneous updates to a case. So this was a huge concern to all the key business stakeholders in the project. The main question was like, what would happen if a case was modified at the same time by a prosecutor and a court admin? Because that would never happen in the real life, right? So this was a huge risk that the key stakeholders thought would happen in the digital world. But this was actually a design smell, because if you remember this single case model and the data-centric view or the database view that backed that model and the implementation, in that world, this was certainly possible. But once we started implementing these models as pre-charge case in its own bounded context, separated from a prosecuted case in its bounded context, and a court case in its own bounded context, and these boundaries were clear and implemented as separate microservices, this problem actually just disappeared. We didn't have to do anything to solve this. So this brings us to the next near enemy, which is pseudo-domain complexity. One clear signal is what's not complex in the domain doesn't have to be complex in the implementation either.
So just while we leave Gayathri wrestling with kind of implementing the higher level abstract concepts that I'd come up with, there's one kind of final part of the puzzle which we needed to solve. And so that's the next kind of key realization, which I kind of came across as I was trying to figure out what our new big picture was. So we'd identified the abstract core, which then meant that we could have multiple bounded contexts, but we could still keep them together and still have some kind of way of having a single view of a case. The question, however, remained, which was how was one view of a case going to kind of turn into another view of a case, which was then going to turn into another view of a case. Because if we solved this, then we would really have our kind of spine of the solution, and we'd have a way of passing things through. So it was clear from looking at things that we definitely kind of had these different views of a case, and that we probably had a flow which would flow from left to right. So a pre-charge case would flow to a prosecuted case, and a prosecuted case would then create a court case, etc. But having known that, making sure that we were aligned closely with the domain and how the experts, who'd used this system for hundreds of years, solved their problems, I was worried that we would be creating something or solving a problem which didn't exist. So I wanted to make sure that what we thought would be the kind of case flow and the creation flow of cases was actually there in the real world. So what we did was, again, we went back to the domain experts and asked them about how does a pre-charged case become a prosecuted case, for example. And it turns out that, as Gayatри's already kind of alluded to when she talked about the preparation of the pre-charge pack, there are not only kind of correlates in the domain, in the real world, for moves from one of these bounded contexts to another, but there's actually legal ceremonies and lots of very kind of specific traditions and things which happen, which, you know, directly map onto these transitions between the different model types in the system. So we had lots of domain richness which we could go into model to find out if we were building the right stuff in the right way. And so we look back and we could see this here, and like I said, you could still see here all of the kind of explicit boundaries that we'd identified in the in our code and that we thought would need to be there in the real world were very much in the real world. So we could see pre-charge case would create a case file. When a suspect was charged, it would turn into a prosecuted case. When that prosecuted case had its first hearing in a court, then it would move to be a court case. And if a simple justice case needed to go to court, it would be referred. So all of these things existed in the real world.
I think we can skip through the slides.
Okay, cool.
So obviously, while we were modeling and talking about the implementation and asking lots of questions deeper and deeper into about the domain, so obviously the conflict was between choosing between implementing what the business defined as the scope of the project versus understanding what the domain is, and that's a conflict that, you know, many can relate to in our teams. So what I would say, my 2 cents on that is, while the scope of the project could change, there's several synthetic factors that could affect it: cost, resource availability, etc. Understanding the domain is always important because it helps us to lay a strong foundation for our models. So very controversially, the next near enemy we're going to look at is minimum viable product, but in the context of modeling, of course. While it's a great idea for what you implement in the scope of the project, when you're modeling, it's important that we don't constrain ourselves to what the MVP defines. So it's always good to learn beyond what's in the scope. So the next one is the as-is and to-be vicious cycle. So obviously we, in any project, even in a greenfield project such as ours, there are legacy systems, and some of the stakeholders like the court admin or magistrates and lawyers come with experience of working and interacting with these legacy systems. So obviously their legacy way of thinking gets carried over. When the objective of the project is to modernize criminal justice system, we are hardly looking at actually reproducing the same flow and some of the challenges of working with the legacy systems in a new tech stack. That's not what we are aiming for. So the next near enemy we have is legacy way of thinking. So it's always important to filter out those and look towards domain, because that changes more slowly than any of the digital system. So it's important to get the knowledge from the current state of the domain out there and model the state that you're aiming to achieve through the software systems.
Learned about CQRS. The reason we wanted to talk about CQRS is because, as we mentioned at the start, it was being used in every single microservice all the way across the system. So we split it into the good things and the bad things. So I'll quickly cover the good things. So CQRS, and as an architectural approach, was a very human-centric way to view the law, because you were looking at kind of independent things which would pass messages between each other, and would be eventually consistent, which was a really nice way to look at things, because it's how the law works as well. Because of this, CQRS and legal systems have time and eventual consistency as first-class citizens. So again, we weren't kind of struggling with a modeling approach, which was different from the way that people conceived of things in the domain itself. So therefore, event-based thinking is fundamentally, when you look at it at an abstract level, event-based thinking is at the core of legal systems, because there'll be a state of the current case or a state of the various players in a case, and then an event will happen and various people will react in different ways, and they might create more events, and then there'll be knock-on effects. So it's a very nice distributed way of thinking about a case with no kind of single controller. And if we're looking at modernization, if we get time plus events, we get history. And if we want to do efficient modernization, if we've got a really rich, queryable, detailed history of how things have been in the past, that will then allow us to kind of work on things and change things going into the future. So for a modernization project, CQRS was a really good fit.
But it wasn't easy. CQRS hardly is easy when you're talking about implementation. And we saw in one of the earlier slides that it's one of the challenges that the team faced. So if we quickly list through the challenges that was posed by CQRS. So if you take aggregates, it's a classic DDD conundrum where it's similar, but not the same as domain-driven aggregates. There are fundamental differences, but this kind of threw the team off when they were talking about two different things that are conceptually slightly different. And lack of explicit model in code, where in CQRS you'd see an aggregate class, everything else is events. So there is no coherent one place where you could go and visualize your model in the code. Then read versus write models, whilst write models are not quickly intuitive, but that's where your domain model is. Whereas read model, when superimposed onto your domain model, it might look like those are your domain model, and that's where you want to spend more time on, but it's important to remember that they are transient. So write is where the domain logic is. And last but not the least, synchronous way of thinking and visualization is very difficult at the best of times and for the best of developers, because we are kind of trained to think of things as request response, but this asynchronous way of thinking and visualizing these events is very difficult. So CQRS everywhere is definitely one of the important near enemies. CQRS is good if you're using it at the right places. And what are the right places? Look into the domain. Listen to what the domain tells you. Where you have these time plus event correlation, that's the best place where you want to bring in CQRS, but definitely not in every single microservice that you have on your architecture.
So we just want to kind of pull together a lot of conclusions by bringing out the themes, which really largely go back to the core tenets of domain-driven design, and the themes are the ones we're going to pull out from the near enemies. So first lot is number one, sit down and listen, especially for the differences. So again, this is core to domain-driven design, listening to the ubiquitous language. Number two, work with the code a lot, because you don't need to just draw models or create models. You need to manipulate them to try and solve your problems, and then you'll really learn if they're good or not. Working as a team, so DDD is for everyone. It's not something which should be handed down from an ivory tower. And number four, don't dilute things, distill things. Try and find the core elements from looking in the details and then bringing the best pieces of that together. Next one, investigate puzzles. Don't try and solve one problem at the expense of another, because if the domain has been around, especially for a long time, it's probably already solved the problem. And so that's it. The domain usually knows how to split up things to solve your big problem into small pieces. And then the last thing, as Gayathri mentioned, a way to fall into a trap with domain-driven design is to be modeling half of something as is and half of something as to be. So it's very difficult to model two states of something at the same time. So that's the slides, all of the slides that we have for you. If there's anybody got any questions or any feedback or anything, that would be really cool.
Cool, thank you. So let's switch back from the sharing mode, right?
Cool.
So let me give some time for people to ask questions, but I got some questions, of course. Great talk. One thing I notice a lot when doing DDD myself is when you read the book, even at the start, it's evident that DDD is for everyone, but every time I hear you talk now again, there seem to be some ivory tower concepts going on. While if you listen to Eric speak, that's the whole idea behind, well, not the whole idea, but one of the ideas that he started DDD, right? So what is your take on why does this happen? Why do, yeah, why is it in this way?
Do you want to answer that, Gayathri?
I'll give it a go. Yeah, you can jump in. I think it is, at least in this project, it was the way the teams were structured. Every team had an architect, so with it, it was assumed that the architects would inevitably take control of this because there's like one person. When you said, like, the teams should own the model, immediately the question was, it was very difficult for everybody to visualize, like, how does the team collectively own this model? Where is the governance process and where is, the controls? It was very difficult to kind of get through to them. And this was only possible by actually showing and demonstrating that this is a collective thing. And this is a new concept for people who have come from, like a traditional team structure and hierarchical organizations.
Yeah, definitely. I think there was, because for it to happen, the architects needed to trust the developers, and I don't think the architects fundamentally, they thought developers were, they built things, but they didn't design things. And so and lots of the developers that we spoke to had the skills, but they didn't realize they had the permission to design things. So they didn't even think about lots of these things. So they hadn't pushed back on, they built lots of these systems, but they could feel the pain. They had the merge conflicts and all of this stuff, but they hadn't pushed back because they didn't feel confident enough to push back. So, and I think that's what Eric's, when he talks about it being for everyone, he wants, it's architecture is a function and a part of the process. It's not a role or a human being that has to do things. But especially in the UK and in lots of other places, people still have the architect as a separate job, right? And that's the person
which is fine as long as it's not ivory tower, right?
Exactly right.
It can be a model that works. I've seen it work as long as you're in between the teams and really work with the teams.
Exactly right. Because this is the thing, when stuff's split up, you definitely do still need to bring things together, because lots of, like, as Gayathri talked, I came up with this kind of thing between the teams, but then didn't spend enough time with the teams to help them bring it into the code, and that caused almost as much chaos as the old way.
Yeah.
But to be fair, you could see, because they were like on the single project, we had so many feature teams and each team having an architect, and these architects had different thinking as well. So some architects actually really weren't ivory tower architects, and those were like our DDD allies. So we would actually use and pick those teams to actually demonstrate how this could be done and how you should bring about the culture change in those other teams where this was not actually a practice.
Cool. And now I forgot my question on that part, because I still find it sometimes when you look at these, because you had, I think you told before you there was another person doing the DDD implementation. Do you think there's a different perception, and where does this perception come from people that DDD are just a set of tactical patterns and not a full development approach, right? Because if you take it as a full development approach, that would be the first thing you do. Try to sit in a room and model together. As it is in there. But every time I see it, it's all about implementation and tactical patterns.
Yeah. I think you could see, I mean, lots of like I said, there wasn't a big picture, so they didn't have a context map, but they had loads of subdomains, and they did lots of good work around technical subdomains. And ironically, there were diagrams that had been done where they had split the domain into different, when we went back, and you could kind of see in the history of the wiki where things have been stuff, and the technical focus, like you say, the patterns as this is a way to solve this thing. They've gone, okay, we can apply this technical pattern and we can bring this together, and we can use all these things to make sure that we do CQRS properly. But in somewhere, the practice of doing DDD had become lost. So again, they weren't not doing DDD. They were doing DDD, but it wasn't spread out and it wasn't democratized. And so the feedback loop from the teams taking the models and trying to build them, it wasn't complete, right? So they could feel the pain, and people could see that they were feeling the pain, but it wasn't feeding back into the design.
Yeah, I think one of the other things that I mentioned in the CQRS challenges in the last slide was, one of the things that CQRS clouded is DDD aggregates, and it's a tactical pattern, right? Aggregates is a tactical pattern. So the very first DDD architect kind of went about like, oh, case is an aggregate. defendant is or person on the case is an aggregate, and they just kind of group things together because of some of the common traits. But the whole concept of bounded context and all the strategic patterns kind of got missed because the focus was on implementing the CQRS aggregates rather than looking into that.
And I think that's what Eric Evans last DDD Europe said. It's not his favorite topic, strategic patterns, but without the strategic patterns, he cannot do proper tactical patterns.
No.
So that's the thing you saw in this case, right?
Yeah, that's
not
the one
enough
that
attention
connects in Juan Vernon's, the aggregate in the implementing DDD book. I had a printout of just that chapter alone because it talks about this connecting aggregates with the bounded context, because once you find your aggregate properly, that's where your boundaries lie, and that is something that is missing in the abstract Bluebook.
And that goes to event storming as well, right? So similar, there's another different angle to find the same thing, but you find your boundaries, you find your aggregates, and then lots of other stuff gets simpler when you found those things, right?
Yeah. And you talked about CQRS, and did you only use CQRS or also event sourcing with it? Because I hear you talk about events and everything.
Yeah,
so can you elaborate a bit more on what parts did you use? Because you said aggregates are a bit different.
Well, so they went full spades, right? So they use CQRS, microservices, event sourcing, asynchronous communication between microservices, and this was everywhere. So they had about 20, 30 microservices across this project, and even at the edge where it's just an API anti-corruption layer where you wouldn't think CQRS, they had CQRS. So they had built a framework, all the things that Greg would say don't do, they actually went and did it, which is CQRS everywhere, or built their own CQRS framework. And once they had built and maintained something in-house, they had to use it everywhere, right? And where I said, it's different in the sense in domain-driven design aggregate pattern, you would think of aggregates as things that change together. Whereas in the actual implementation of how they had done, like I said, they kind of went about and looked at common traits to identify the aggregates and to store the state of that as events. So if you look at the code, there will be one microservice called case, that was the name of the microservice, which had an aggregate called case aggregate. And it would have some validation, which was the business rules, and they had methods to kind of replay and reconstruct the state. So this was not kind of what you would think when you talk about domain-driven design aggregates, right? So you would think that if it's a case, there's a specific type of case because that goes through a few steps in the prosecutorial process, for example, prosecuted case. And there is a defendant, that entity you would expect to see within the prosecuted case, and some materials, case materials that is related to that. There will be a victim entity, which is not something that is applicable in a court context, for example, because in the court, until the person is convicted, there is no victim. Everybody is a witness. So you see all these richness come through in your implementation. But when you actually look at the bare bones of it, I asked Greg on Twitter, where can I actually see this in the implementation? And he went like, you can't really, unless your domain logic or business validations and rules actually need to include these objects somehow into those business rules. You can't actually see it. They're all distributed as events, right? So if you go in there will be like a defendant created or a suspect charged would be an event which has a reference to the case ID. So it was kind of distributed across these domain events. It was quite explicit as you would expect in DDD. It's all about explicit modeling, but you don't see that come through in CQRS implementation.
Yeah, so is that because I hear you talk about they also stored the events and not the actual state of the aggregate. So that means were they doing event sourcing with it then?
They are storing the event, so you can only see these entities being related if you actually looked through the events. But
So it was CQRS with,
but it was literally a history of exactly, like just a history. So to get to the current state, you would always replay all the events. So it's like pure, super pure.
Yeah, because you can use CQRS without event sourcing, right, as a pattern.
Absolutely right. So that's the concept that kind of escaped them.
Yeah.
Okay. No. So I was thinking it was only about CQRS, but now I can imagine.
With the event
sourcing. CQRS with event sourcing, and the framework took care of reconstructing the state as well, so it would just replay the event.
There's cool. And so one thing, what I don't see a lot in talks is the abstract core. I find it
exactly right, because it's in the book, but I've only ever it was kind of scary to
you don't see it a lot, only in really big domains like this.
Exactly right. And this was the
dive
thing.
a bit more into that.
So it was it took me a long, because I'd read about it a long time before, and like I'd used it in another project where we didn't need to use it. So we just, because, like Gayathri said, it's a bad smell to have a thing which is shared between teams, right? So lots of the stuff in DDD is just a really clever way to figure out how to split things up. And then it gives you license to duplicate things because you've got two different models. And so it was scary to begin with to kind of realize that maybe this needed an abstract core. And the reason why, so the reasons why I was happy to kind of bring it in were like I said, listening to the domain experts, it turned out they had this, especially with case materials, because case materials doesn't really mean anything at all. Whenever you speak to a domain expert about their core domain, they always talk about a lot more specific things, like the police talk about pieces of evidence and statements. That's all they talk about. And then, and they'd only reserve this kind of specific domain language for these conversations, which would happen across, because there was kind of a flow of a case through the system, but at many points, the same case would be in 3 different views happening. The prosecutor would have a view, the police would probably be involved because they would be witnesses in court. Things we didn't show, but the defense solicitors would also have their view of things, and we provided some endpoints for defense to kind of get access to some of this stuff, and the courts. So there were times when they would be kind of exchanging things and passing things around, and they did, so we realized this, and then we were like, right, so what are the words you use? Do you use, like suspect was another clue, right? So they had a real word for, not suspect, subject. They had a different word, which we didn't invent, which they used to talk about things when they didn't want to say defendant or suspect, because they knew that it was different. So that was our first clue. Then the fact that we realized that we could still do, achieve all of our modernization goals. So at one level, we could still have, you could say to the people who wanted a single view of a case, you still have a single view of a case, you just address an abstract case. And you can always rely on these things. And then you could also say to the people who wanted their view of a case, this is your view of a case. And because the abstract core was very small, and we tried it, like I tried it with a few developers in one team, and it still worked. And it gave them freedom to have a richer kind of view of a case, but they could still make sure they met this kind of requirement for a shared case.
But it's funny in a way that, it's not just a case, right? So even as simple as address, when, it kind of, the case passes through context, the address need to be, address line 1 to 4. So that was completely different in each context. And you can imagine when the case kind of goes through this process, when this is handed over to court, for example, you need the address to be right for all the correspondence with, you still send paper-based prosecution notice. And if that didn't actually match, that's not going to work. And it's as simple as that, but still, that is the abstract core that needed to be shared, a shared library, the shared kernel that Eric talks about. That was it.
And it was good, actually. The other thing, the thing that I kept going back to, and this is where I keep going back to the Bluebook. If so the patterns are really nicely written, because you would, you'd read, Eric, he's got this is the problem. You would read his description of the problem that you should find yourself in. And they're very specific, right? You can, if you read it and it is your problem, then it's a pretty, I now trust it more, because I was a bit scared. I was like, this can't be. I'm a bit scared to do this new thing, right? And then, but it just works. It worked really well.
Yeah, I can imagine it works, but there's also the downside where it's an abstraction, which creates a shared kernel, and people either they abstract everything away, what you said at the beginning, which is really dangerous, especially when it doesn't have the domain riches. So I think a key element here is listen to your domain and check and recheck if it's there, and only so I think what I hear from you is only abstract away when it's really a rich domain concept, and then use the abstract core.
And that's and the abstraction was in the domain as well, and that was cool. That was kind of a real. I never realized that a domain, because this is the thing where, you know, which reinforces your faith in the the genius of domain-driven design. You know, this problem, especially in a domain that's a few hundred years old, as this legal system was, right? They'd already solved. They had this problem in the 50, 60, 100 years ago, and they solved this problem themselves. We just had to find it and then go, okay, we can use this and we can put this in our code. It was amazing to kind of realize that we were just, you know, the implementation was different, but it was.
Yeah, and the beauty of it is this is the one part where all the teams had to collaborate and agree, because, you know, one team can change something in the
so
shared
that was
kernel.
my question there. You mentioned shared kernel and on that one, because it's actually a good pattern when there's the discipline, right? So how did you deal with that, Gayathri?
So this was a compromise, right? So this is coming from team to where like super coupled, and they've been trying to break away. So if you present to them like, you know, this tiny slice of things is where you need to agree and make sure that you have covered yourself with tests. And make sure that you all agree. And this is a small sliver that changes very rarely once you have come to an agreement of what they should be. The number of address line fields are not going to change. The fact that there has to be a defendant or case material should be there is not going to change. Any new additions is, you know, quickly you could organize a meeting, you know, pull the right people together and just implement it. And it's a very small piece of code, and it's not a lot as used to be. So that was like a really easy sell for me, because, you know, coming from this whole load of code base that they were sharing, they just needed to share this one single library.
It's not a canonical data model, right?
Oh yeah, exactly. Yeah, it's very definitely not a canonical data model.
Yeah, great. So I think we're out of questions now. So we're already 1 hour 11 in. So I have one final thing to wrap up, and that's your advice. So if you can give one piece of advice when you want to combat near enemies at scale with DDD, what would your advice be? What would be the first thing people can start doing tomorrow? It can be a small piece of advice or can be a big piece of advice, but one thing that they can start to pick up. What would that advice be?
Well, I think it was in one of our last slides, summarizing the key in your enemies is a listening to the domain. And I know it's a cliche and it has been said like a million times, but that is, you know, a key point that never goes away is to listen to domain, and it never lets you down to do that.
Yeah. And so and that's my point, kind of builds on that actually. So I think, I can't remember what I heard. I think it was when I did my domain-driven design immersion course a long time ago. And the person who trained us said that your domain experts are, so your developer, your domain experts know about the domain but don't know how to code. So together, that's how you solve the thing. So if you both treat each other with equal respect, you know, they'll know, you know, if you've got good domain experts and you know, that was fundamental to this. We were very lucky that someone had gone off and found people who lived in these worlds, and we had them sitting with us all the time. That was very key. You know, just trust it, you know, not going, whenever we thought we were cleverer than them, it was a trap and we fell into it. As soon as we respected them and learned and we're like, okay, why? What's the history of this? Why does this happen? What's this? it was the clue to so many things. So listening to the domain and then like trusting them and realizing if it was simple, it's because it didn't need to be complicated. And if it was complicated, it's because it couldn't be simple.
Yeah.
And that was, it solved so many problems just by doing that. So.
And I know you said one advice, but this is based on all the conversations we had once we finished the talk, because there are always people who are battling with a current situation where they want to introduce domain-driven design, right? So I think this is more relevant, is to start small, take like a low-hanging fruit, start and demonstrate the benefit, and then go for like the full-blown DDD approach.
Yeah.
Yep. Awesome. Cool. Well.
Cool.
We're going to close up.
Thanks,
we can keep in the Zoom, but I'm going to close the stream for YouTube.
Cool.
Thank you, everyone, for watching this, I think, the last VDD of this year. And next year, there will be in January, we have some cool announcements the coming weeks. And you already see the live event storming online, which I'm really looking forward to how that goes. Yeah, cool. Never done it myself, so check that out. And if you have feedback, questions, or anything, let us know. You can find everything on Twitter, and we'll be putting the podcast up online soon again. Thank you very much. And thank you, Gayathri and Andrew, for showing this.
Thank you. Cheers.
Awesome. Thank you.